Everyone, today I'm going to talk about 122 best time to buy and sell stock second version. The question is, you are given an integer array prices, where prices I is the price of a given stock on the ith day. On each day, you may decide to buy or sell the stock. You can only hold at most one share of the stock at any time, which means I just only can buy one, right? However, you can sell it and buy the stock multiple times on the same day. Okay, I can sell it and buy the stock multiple times on the same day. Ensure you never hold more than one share of the stock. So find and return the maximum profit you can achieve. Okay, I can buy multiple time and selling multiple time. This is different from the first version. You can see here day 2 for this one example, buy on the day 2, right? And selling on the day 3, we got profit 4. And then buy on the day 4 and selling on the 5. This one profit. Okay, so first thing is to analyze this first. Analyze this first. The purpose goal is to find the max profit multiple times buy and sell. Okay, this is the condition. So find this thing. Okay, so we can think of take this example. So we can think about in this way, right? The last day, and if this length is n, so n's profit n minus 1 profit based on the 0 to n minus 2 profit day. Okay, and then this one based on the 0 minus 3 days profit. And this one minus equal to, this one from 0 to 0 this 4 day, and until the first day, we will become the first day, 0 to 0 day. So this look like if we know this one, this is subtext, right? Then we can get this one, get this one, get one, get one. Then we can get the last day. That is what we want. So which means we have some conditions. So this is kind of like we can write some tree like minus 1 for this one, minus 1, and previous if like whether hold or not. So we can use the Boolean point to like hold or not. Hold equal to 1. So for the previous, we can have 2, 1, and minus 2 is equal to 0. There are two situations, and these two situations will impact this one. So based on the different things, we can have the two different, suppose like if n minus 2, 1, which means hold one stock, so which will impact for this, we have the two decision, it's assert it or keep hold. And if minus 1 didn't have no hold, one stock, no stock, so which current here we can have two decision, buy or keep, not buy. So it's kind of like there are two situations, 4 situations, right? So you have to hold, and then you will become, this is not hold, and you become a hold. And for this one, you can do nothing. For here, it's also do nothing. But for here, you can not hold. You can buy one and then become hold, and also hold also can do the things. It's like a third. So we need to do this, right? Based on this situation, then pick up the maximum benefit. So this problem, so the solution is use like a DFS. Start from the last one, like a last one, and also we have the prices, right? This is called like a benefit, profit. Use the benefits to do this, and during the DFS, it can be DFS stuff from here. Yeah, use the DFS to do that. So when it stop, it's like if current here, right? Start from 0, smaller than 0, which means we didn't find anything. This is treated as like beginning. So if the I smaller than those, so we have some hold. Like if current here hold is equal to 1, which means not good. It's impossible because the first day you cannot do anything. So it can return like an integer minimum value to treat it. It's not good. And if hold is equal to 0, then we can return 0 because the first day is 0 profit. Then we can go into the, this is like a, if this is a tree, right, it's in the bottom, and then you have to go back. We can have some situations like treat, and then we can write the conditions like here. We can write this one. This is the main logic here. To do something here. And for the time complexity is the use the DFS, and we have the 2 branch actually, right? So it will be the to n. This is the draft solution. And the space based on the stack, right? So it will be the O n here. Now we can write this code now. So at the beginning we have the prices. Yeah. And we want to use the int result equal to the DFS -1 and prices. And also at the beginning, the last thing you have to sell it, right? So we can start from here, which means 0 means not hold. We cannot buy anything for the last day. It's always you have to sell it before the last day, include the last day. So return the result. Int DFS int I equal to and int hold int prices. So we can write here. The first is here. If I smaller than 0, then we have to check, because we start from the last one to assume what happened the previous one. So when we really here, right, we have to move something impossible. This is what this condition is doing now. So if the hold is equal to 1, which means it's not available, we need to return the integer max minimum. And otherwise which means hold is equal to 0, so it's okay, so we return 0 here. The first day is the 0 profit. Okay, so for now we have some conditions to translate this, right? So we have to check if the hold equal to 1, we have some situation to do. Is so you can sell it or keep hold. So return, but we want to the maximum profit, so max DFS previous one. Current one is hold, so which means this is previous one. So there are two conditions, which means previous hold or current buy. So if the previous hold is like this, we didn't do anything. It's already have included benefit. And for here, if current buy, which means DFS I -1 didn't do anything, but we buy current now, so we need to minus the prices, like current I. So this got a little tricky here. And then for this one means the hold is equal to 0. So there are also two conditions, is previous already sell it or current sell it. So return the maximum DFS I -1, previous is 0, or DFS current 1 -1. This is previous, and selling at current time. Yes, you can check. Yeah, it passed, but the time is very large, so it will encounter some. Let's see. So time exceed, so we have to improve this. which means during our do something, there's some this tree has some duplicate. Like if we can drop this tree more 4, so a minus 3, this has got like a minus minus 3 0, right? And for here you can see same, it will have some like minus 3 1 whatever, minus 3 0 here. There's something duplicate, so we can use like memorize to start the repeating one. Like if for this one is like start from here, it will go through this tree first. So during this one, some subtrees will already calculate, and it will same happen. Then you can see here and go back to go this way. This way, this one is already calculated, so we can use something to store the memory, and instead of we have to do the tree again. So this is to avoid the duplicate part. So we can create a memory. We have to store this hold, and for the prices, so we can do this. Yep, so we can put it inside. For here is okay, so we can check before we go into this one. So member, if we see before is I and hold is not equal to -1, then we can return the member. This one. And for here, we can store the member. Here. And the same situation here. Here. You can see. Oops. Yep, you can see this test case is path. Yep, the time complexity will be changed because here we just created to scan the DFS, right? So the time complexity will be the O times 2, and space will be the O(n). And for here you can see it's O(n). Thank you.